My name is Gandeep Kambar, and today I'm going to talk about my final project, Options Premium Analyzer. It's a cloud native serverless application which is designed to analyze the stock options contract. Currently, in its prototype, we are trying to evaluate only for the Magnificent Seven stocks, and the system is responsible to identify the top three most profitable trades. It automates the data collection, its processing, analysis, and providing the results via REST API. The flow begins with the data fetching lambda, which is triggered by CloudWatch event page trigger, and this lambda is responsible to fetch options data and the stock data from the external APIs. And it's also responsible to save the raw data into S3. Then moving on, we have the AWS Glue ETL jobs, which are responsible to transform that data and help calculate the premium percentage across all the contracts. Further, we have Ethna, which is responsible to run the SQL analytics on the process data to help us rank trades by the profitability. And finally, we have an API gateway which exposes a REST endpoint backed by another Lambda, which executes these Ethna queries and returns the top three trades to client in real time. The each of the components of the previously discussed architectural diagram little in detail. We'll start with the data fetching lambda. So this is our data fetching lambda, and as you see, it has a CloudWatch event trigger. Currently it's scheduled to run once in a day at around 2 p.m. EST. And in the code, if you see, in the lambda handler, we are iterating through each of the Magnificent Seven stocks, and for each of the ticker, we are calling this fetch options data. This method is responsible to fetch the live or the most recent data for that ticker, including its stock prices and the option contract prices. I'll go through that, and in the broader scheme of things, this is just fetching all that data, and then finally we are storing it all the raw data into the S3 bucket. So this is the high level purpose of this lambda. Within this fetch options data method, it's calling first the get current price. This method is calling a different API from Polygon. So we are using Polygon as our external partner to get the stock related data. And in order to use Polygon, we have to use its API key. So that API key is currently set into our environment variables over here. And so going back, so it gets the current price, and then we use a different API for getting the options contracts. And one thing over here is, since I was using the free tier of Polygon API, I was facing a lot of issues with the rate limit. So I just reduced the scope slightly by just getting one strike price for each contract, for each ticker, just above its current price, and then using that data to compare and get the most profitable trades. But in the larger scheme of things, it won't be limited to just one strike of the of per ticker. It'll pull multiple strike prices for each ticker, and it could also result that the most profitable trades has the same ticker different contracts. So yeah, so once we get that options data, we are just massaging the data the way we want to have it stored in our S3, and finally we are just storing that data into the S3 bucket. And this bucket is the one where we are, if you see, we are having the raw data stored every day because the cron expression was scheduled for once a day. And then the other bucket is where the process data is being stored, from which the Ethna is querying. To review AWS Glue, which is used for the ETL processing in our application. So we created the crawler. If you see here, we created this options crawler, And if we go inside that, we created a database by the name of Options Analytics, and it's currently scheduled to run daily at 7:30 p.m. UTC, which is like 2:30 p.m. EST, and it's running 30 minutes after the data fetching lambda runs and stores the raw data into S3 so that it processes all the latest data it fetched from the Polygon API. And if you check the data source, it's sourced from the same S3 bucket which contains that raw data. And if we go to the tables, we can see it created this new magnificent 7 options from the Options Analytics database, and we can view the table details by routing to the Ethna. So currently, if we run this, so with the limit 10 query, it returns us the 10 results of the from that table. We'll show the Ethna query, which is going to be used in our final API gateway lambda to get the most recent contracts from the 7 tickers and help us get the top 3 most profitable ones. So this is the query, and once we run this, we get the 7 most updated, most up-to-date contracts. Now we are going to go through our final component, the lambda, which is having a API gateway exposed via REST end client. So this is a API gateway endpoint we are going to test via Postman after this. And if you see, it has a get call, and if we go into the code, it basically queries Ethna, the query which we just saw, and once it makes that query to Ethna and gets the results, we have kept 3 retry attempts in order to handle the failure scenarios. And once we have the results, what we do is we basically try to find the profit score for each of the contract from that result set, and this profit score is nothing but how much is the strike price of the contract plus the premium which you are paying differs from the current price of the underlying stock. So the smaller the difference means lower premium you are paying for the future date contracts. So this is an important factor for us to see what are the most profitable trades. So it calculates that, and also we have added default values for the underlying metadata, kind of a synthetics, just in case we don't get the latest price from the external APIs. And once we have this, once we have the profit score, we try to sort all the contracts based on this profit score, and then we return the top 3 most profitable from this sorted list. Now we'll test the API gateway endpoint via Postman, and as we saw, it was a get call. I made the call to the underlying endpoint, and we can see we got a 200 success response, and it returned us the top 3 option contracts, and they are in the order of the most profitable one, and it has all the other data elements of like the current price, the strike, the option price, what was the open price of the contract, high, low, and the profitability score which we discussed. And the most profitable contract will have the lowest. So if we see the profitability score increases, and this basically identifies or indicates that the strike price plus the premium you are paying for the contract is closest to the current price, so you are paying less premium for the future contract date. And yeah, so these were the 3 most profitable trades returned by the API. So now in our final section, we'll go through the different setup guides and the packaging structure. This package lambda sh, it's used for our data fetching lambda, And in this, first we create a new directory by the name of Lambda package. And within that Lambda package directory, we install all the external libraries required for this Lambda function. And if I go into requirement.txt, we just have the requests and Boto3 library which are used for this Lambda. And once we install, we just create a zip for that. And once we have that Lambda deployment zip, we upload that to our AWS Lambda console, and followed up by just some of the cleanup activity. We'll go through the AWS Glue Ethna setup document. This document outlines steps to set up Glue and Ethna to help us analyze the options data which is stored in the raw S3 bucket and help us find the most profitable contracts. Prerequisite for this is to have the data available in the S3 bucket, and once we have that, we create Glue database. In our case, we created the options analytics as we saw, and next we go to the crawlers, and we created a new crawler by the name of options crawler, and we mapped its data source to our S3 path, to which the data fetching Lambda stored all the raw data from the Polygon API. And we also set some IAM roles in order for the crawler to access the S3 location. And it's currently scheduled to run once in a day at around 7:30 p.m. UTC, which is around 2:30 p.m. EST. And this is set with an intention that it runs 30 minutes after the data fetching Lambda, so that it can work on the most recent data. And once this is done, what we are going to do is we are going to create a new table in Ethna. I created it manually to map to the source. And finally, this is the query which is going to be used in the final API Gateway Lambda to call to get the most recent options for each of the Magnificent 7 tickers, amongst which we'll try to find the profitability score and return it back to the client. It outlines the steps to create the API gateway and how to configure it with the underlying Lambda function which we are using. So for this, once we have the Lambda function created and which has a proper IAM permissions for the S3 and Ethna, we can go to the API Gateway console, create a new API, a REST API, and give it a name. In our case, we had it as Options Ethna API. Provide the description, which is an optional, and then endpoint type we marked it as regional. And once we create it, we go on to create a resource by the name of options, which we are using as our endpoint, and we enable the API Gateway course. This I learned the hard way while encountering the issues. And then we added a get method, since it's a get call for us, and we create using that create method, we selected the get in that drop down. And finally, we do the integration of the Lambda function to the API Gateway. We select Lambda function as integration type and select our specific Lambda and the region in which the Lambda was created, and that way we integrate the Lambda to the API Gateway. And also there were few other troubleshooting things related to course and testing on Postman, which are outlined in this document. Includes my entire presentation along with the different setup guides. Thank you very much.